In this video, we perform a clean installation of macOS Catalina on Windows 10 using VirtualBox. Hello everyone and welcome to TechFixFlix. In this tutorial, we create a macOS Catalina virtual machine running on VirtualBox for Windows. Unlike many other tutorials which use a pre-created hard drive file as the basis for their method, ours is a clean installation. The roadmap for the tutorial is as follows. We will run a third-party downloader on a macOS machine to download a full copy of the Catalina installer. We will then use the terminal app, available by default on macOS, to enter 6 commands, which will convert the downloaded installer app into an ISO file, which we can then export to Windows. We will run VirtualBox on Windows and create a macOS virtual machine, modifying the configuration as necessary before attaching the ISO we've created. We will then add 6 lines of extra data to the virtual machine settings using the command prompt in Windows before running the first phase of the macOS installation. After that, we navigate through the boot sequence to reach the second phase of macOS installation. At this point, we install 3 driver files to provide APFS support to VirtualBox, which is otherwise natively unavailable. With APFS support added, we modify the startup file to incorporate these drivers and load the remainder of the macOS installation. We then simply personalise the installation and head to the macOS desktop. We'll also look to provide keyboard and mouse support within the virtualised environment. Despite the length of the process, there's nothing complicated or requiring specialist skills here, and we'll walk through each step. This is our 4th tutorial installing a Mac operating system on Windows, and we build upon the foundations laid in our previous tutorials covering High Sierra, Mojave, and Catalina Beta. For those of you who've watched our previous videos, there are improvements upon our method here, particularly in respect of loading from the EFI shell, which was an issue in the past. Once again, the commands entered in Terminal for Mac and at the command prompt in Windows should be credited to their original sources, and you'll find extensive reference to this in the written descriptions of our previous videos. If you're interested in future projects like these, we'd love it if you were to subscribe to our channel. We've been asked many times to post the ISO created during the first phase of the tutorial to assist those who don't have access to a Mac. Whilst we fully understand the reasons for asking, we won't be providing the ISO as we're confident that this would be a breach of copyright, and we certainly have no intention of placing ourselves in legal jeopardy by reproducing Apple's copyrighted material. So you will need access to a real or virtual machine running macOS to complete the first phase of the tutorial. If you're truly desperate and without access to a Mac, there are certainly options available to you, and a simple Google search will reveal options to download pre-built hard drive files, which may be a solution for you. Notwithstanding, we dislike these solutions on security and privacy grounds, purely because you have no way of knowing what a pre-built hard drive will contain, and we prefer the clean installation method advanced in our tutorials. Although we're using a Mojave virtual machine in this example, any modern version of macOS will work, even those which don't offer an App Store Catalina upgrade. We begin by navigating to the web address shown on screen now and in the written description accompanying this video. We click on the link labelled Download Latest Version to begin. You may be wondering at this stage why we simply don't download from the App Store, and there are 2 reasons for this. Firstly, the App Store won't offer the download on machines which don't meet the minimum recommended specifications for Catalina installation, so users of older machines will be denied access to the store by default. The third-party Patcher utility used here is specifically designed to work around this. The second reason is even more significant for our purposes, as it serves to standardise the installer used in the next phase of the installation, and this is crucial when entering commands in Terminal, which make assumptions about the structure of the installer app. Without a standard starting point, sourcing the installers from various locations on a bring-your-own basis takes away that control. Using a standardised approach is certainly a lesson we've learned from previous installations, and whilst we're fully aware that this type of tutorial attracts exactly the type of user who likes to experiment, we would urge you to follow the steps in this video as closely as possible, as each step is highly dependent upon the last, and branching out can lead to difficulties. It's for this reason that starting at the same point, by downloading the same installer app, is significant. Once the installer has downloaded, we click our download stack and click to open macOS Catalina Patcher.dmg. The DMG mounts, and once opened, we click to run macOS Catalina Patcher. The patcher runs, although we don't make significant progress, as it can't be opened as a consequence of the default system preferences, which prevent software from an unidentified developer running without specific permission. We therefore click OK to clear the error, and then navigate to System Preferences, from where we click the Security and Privacy options. Here we see the previous error repeated, and we can provide the required permissions by clicking Open anyway. Even this attempt to open requires a secondary confirmation, and we therefore click Open from the drop-down. The Patcher tool is now running, and we simply click Continue at the introductory screen, as well as a second time through the Contributors screen. At the next screen, we'd highly recommend selecting Download a Copy, even if you already have one, in order to standardise the starting point for the next phase. We are now in a position to click Start Download, and the download commences. On most connections, this will take some time, as the download size heads toward 9GB, so this may represent an opportunity to take a break. Once downloaded, there's a shorter installation phase, after which we're required to choose our installation method. As we clearly aren't installing to this machine, we can rule out the first option, whilst the output of a bootable installer option will be incompatible with Windows. The option to create an ISO image seems ideal, and could eliminate forthcoming steps in terminal. However, we tried it twice, and the ISO created couldn't mount on Windows, and appeared as though corrupt. Hopefully, this may be a feature which can be used at a later date, but for now, we instead close the application. At this point, we can optionally clean up by right-clicking on the mounted installer and selecting the option to eject. We can also open our Recents folder and select the macOS Catalina Patcher.dmg. Right-click and delete it. And we'll also remove it from the trash before confirming our intention to empty the trash. Now that we've tidied, we head to our Downloads folder, where we find the outcome of the download, an 8.1GB installer app. The size may alter slightly if you're watching this sometime after the initial public release of Catalina, but this is certainly appropriate for the initial release. We need to copy or move this to our Applications folder, purely because the next phase will assume that this is where to find it. So we select the option to copy, navigate to the Applications folder, right-click, and select the option to paste item. In the alternative, click and drag works equally well. We can now see the installer app within the Applications folder. Whilst within the Applications folder, we use the search field to search for terminal, then run it. With terminal running, we now enter the 6 commands shown on screen now, pressing the Enter key after each. These commands are also reproduced in the written description accompanying this video, allowing you to cut and paste them for accuracy, and all of the typed commands in this tutorial can be found there. The first command creates a temporary volume, where we will create our installation ISO, and after a moment, we see that it's been successfully created. The second command mounts the volume we've just created, and this is visually represented on the desktop. The third command creates the installation media. To authorise this, we need to enter a password, and this is nothing more complicated than the password which is used to log on to the Mac at startup. Note that the password is entered invisibly, and there will be no asterisks to show your keystrokes. With the password successfully entered, a brief processing phase follows. Upon completion, we are notified that the install media has been successfully created. The fourth command ejects the mounted volume, as the fifth and sixth commands can only be performed once it's been unmounted. Again, we see this visually represented on the desktop. The fifth command converts our DMG file to a .cdr, and after processing, the CDR appears on the desktop. The final command converts that CDR to an ISO. Once complete, we have an ISO which can be copied to Windows and attached to a virtual machine in VirtualBox. We now close terminal. From our previous projects, we're aware that the simple task of transferring from Mac to Windows can lead to accidental corruption of the ISO file, so we check the size when leaving macOS, and again upon arriving on Windows to check its integrity. A checksum is even more definitive, but beyond the scope of this tutorial. We right-click and select Get Info. Our ISO size is 8.91GB, which is certainly appropriate for the initial release of Catalina. Anything substantially less should be a cause for concern. Once transferred to Windows, we'll be checking to ensure that the received size matches. If you've made it this far into the tutorial, we will assume that transferring a file from macOS to Windows won't present a challenge for you. And after transfer, we arrive on Windows with VirtualBox running. If you're new to VirtualBox, we've created an installation tutorial at the link shown on screen now and in the written description accompanying this video. We click New to create a new virtual machine. Our first task is to provide the virtual machine with a name. We name our machine simply Catalina. Although this is an entirely free choice, Be aware that we will reference the name in future typed commands, so you will need to modify them if you call your virtual machine by another name. We select the type drop-down, changing the value to macOS 10. With that value set, we select the version drop-down, which we set to 64-bit. With the basic details in place, we are ready to click Next. The default RAM size is set to 2 GB. We increase this to 8 GB. Our host machine has 64 GB of total RAM available. The rule of thumb here is to increase in multiples of 1024 MB, whilst ensuring that we leave enough RAM for the normal function of the machine. And we shouldn't allocate more than half of our total RAM to the virtual machine. Unless you have specific reason not to, we recommend accepting the default at the next 3 screens. First, to create a virtual hard disk now by clicking Create. Then accepting the default virtual hard disk file type, VDI, by clicking Next. Finally, we accept the default dynamically allocated to allow hard disk size to grow as needed by again clicking Next. The default hard disk size is set at 20 GB. As we're purely testing, we increase this slightly to 30 GB. In a real-world scenario, we'd probably allocate far more, depending upon how much use we intend to make of the virtual Mac and the amount of space available on our physical PC. We click Create and the machine is now created, although there are still settings to be amended. We right-click the virtual machine and select Settings. From the General section, we navigate to System, where we untick the obsolete Floppy option. Then we move to Processors, increasing the CPU count from 1 to 2. Without this change, the virtual machine will not boot. At the Display section, we increase the video memory to the maximum 128 MB. We then move to the Storage tab, where we click the empty virtual disk. We click the drop-down disk menu and select Choose Virtual Optical Disk File. At this stage, we need to locate the ISO created in the first part of the tutorial and transferred from macOS. We select it and click Open. Our ISO is now mounted in the virtual optical drive. Our machine is now configured but not complete. We need to enter commands via the command prompt, without which the virtual machine will not function. From the desktop, we click the Start button and search for Command Prompt, selecting the option on the right to run as administrator. Where user account control interjects, we simply click Yes to provide our consent. The command prompt now appears. The commands which we will enter here are reproduced in the written description, enabling you to easily cut and paste. Our opening command will navigate to the VirtualBox installation directory. This is the default, but if you've installed VirtualBox to a custom location, you'll need to modify this command accordingly. This is the only command which will be visually confirmed, as the others won't generate any form of response. We now enter the 6 commands, pressing enter after each. Previous tutorials have prompted questions about the role of these commands. We aren't the original authors, with sources credited and quoted in the written descriptions of our previous videos. And it's suggested that their origins lie in the Hackintosh community. It's clear that our virtual machine won't boot without them. Note that the commands assume that the virtual machine was called Catalina when set up. If not, this needs to be amended accordingly in each of the 6 instances where our virtual machine is referenced by that name. An optional final command will change the resolution for the virtual Mac. Here we select 1920 by 1080 to match the resolution of this video. Your option may be different, and these values can simply be modified to match your optimal screen resolution. With all commands now entered, we can close the command prompt. We return to the desktop and rerun VirtualBox. At this point, we can run our virtual machine for the first time. Incidentally, should your keyboard or mouse freeze at any point within the virtual environment from this stage onward, we cover keyboard and mouse driver support as a separate topic at the conclusion of this video. At startup, you'll see a great deal of white text on a black background. As is traditional, we would advise you to disregard any error messages which may lead you to conclude that the virtual machine is failing. Provided that you continue to see activity on your drive light indicator, and provided that the text keeps scrolling, everything will be fine. Eventually, you'll see the Apple logo, a clear indication of progress. A short phase of processing will be indicated by the status bar before the screen darkens and we're taken to the language selection screen. We select UK English, and you can make a choice appropriate to your localization. With the language selected, we head to macOS Utilities. A common and entirely logical mistake here is to select Install macOS. If you're following our steps here, don't follow the next few, which are shown purely to illustrate the problem. If we select macOS, then Continue, progressing through the installation screen and accepting the license agreement, then confirming, we reach the installation screen with no disk available upon which to install. It's at this point we realise that we've made an incorrect choice, so we revert back to macOS Utilities, and you can once again follow our steps as we head to Disk Utility. At the Disk Utility main screen, we select VBox Hard Disk Media and click Erase. A drop-down appears, and we make a minor, entirely optional amendment to change the disk name from Untitled to Macintosh HD. We then click Erase. The erasing process begins and has the effect of formatting the disk, thereby making it available to the installer. Once we receive confirmation that the disk has been erased, we click Done, then click to exit Disk Utility. We are returned to macOS Utilities, where we can now safely select Install macOS. We again progress to the installer screen, where we click Continue, before again clicking Agree at the Software License Agreement screen and confirming our agreement at the drop-down. Now we have the option to install onto the drive we named Macintosh HD, where previously we had none. We therefore select Macintosh HD and click Install. There follows a brief installation phase before we are returned to a new screen of white text on a black background. Don't be discouraged by the opening message that boot failed, as we are right on track. You should, however, be aware that we are now in a boot loop, and without further action, we'll be heading back to the installation phase we've already completed. It's time to close the virtual machine using the icon in the upper right corner and select the option to power off the machine. Our installer ISO has now served its purpose and the moment has come to eject it. We therefore return to VirtualBox, where we right-click our virtual machine and select Settings. We move from the General Settings tab to Storage, where we select the Catalina ISO, which we will now eject by clicking for the drop-down menu, where we select the option to remove disk from virtual drive. The virtual optical drive is now empty, and we no longer seek to boot from it. With settings closed, we can now return to the virtual machine. With our boot disk now absent, we arrive at the shell prompt, where we type Exit. The following series of screens are navigated using the arrow keys, with Enter pressed to select an option. We therefore use the arrow down key to reach the Boot Maintenance Manager before pressing Enter. At the Boot Maintenance Manager, we drop down to select Boot from File. With two options at the next screen, we drop down to select the lower option. At the next screen, we drop down again to select macOS Install Data. With only one option available, we select Locked Files at the next screen and Boot Files thereafter. Finally, we drop down to select and run boot.efi. This takes us to a further phase of white text before we're again returned to macOS proper, where the screen darkens before we enter a second, longer installation phase. This secondary phase is significantly longer than the first, and we can comfortably take a break here as the installation progresses unaided to its conclusion. The machine will automatically restart, returning us to the shell prompt. At this stage, our installation has progressed as far as it possibly can without APFS support, and can progress no further without it. As APFS is not supported natively in VirtualBox, we need to provide that support via an external source. We therefore again exit the virtual machine. In our browser, we navigate to the tech blogger's APFS EFI ISO, a very small download containing just 3 files which enable APFS volumes in VirtualBox, available from the link shown on screen now and in the written description accompanying this video. We click Get It Here and are taken to a Google Drive shared folder hosting the ISO file. We right-click that ISO and select Download, which downloads the 1MB ISO file, which we now attach to our virtual machine. With the ISO downloaded, we return to VirtualBox, where we right-click the virtual machine and select Settings. We move from General Settings to Storage, where we select the virtual optical drive, which is now empty. We click the drop-down menu, once again selecting Choose Virtual Optical Disk File. This time we navigate to the tech blogger's APFS EFI ISO and select it before clicking Open. The ISO is now attached to the virtual machine and we are ready to rerun. Upon running the machine, we are returned to the EFI shell. We could simply load the APFS drivers from the virtual disk on each subsequent occasion, but a far more elegant solution is to copy them from the virtual optical disk to the virtual hard disk, then incorporate them into the startup sequence, making their presence transparent for each subsequent run. At this stage, we have FS0, our primary hard drive, and FS1, our virtual optical drive, containing the 3 files we need to copy. We type FS0: and press Enter. Our next command will therefore apply at FS0. Now we type copy -R FS1:/EFI, then press Enter. This will copy the EFI directory from FS1 to FS0, in other words from the virtual optical disk to the virtual hard disk. Incidentally, keyboard mappings may be an issue here. The / we required had been mapped to the hashtag key above right shift on our British English keyboard, and we've been made aware that the colon may be mapped to a different key on some keyboard layouts, so you may need to experiment to find the correct key. We see confirmation that the EFI directory and its subdirectories have successfully copied. This means we can now use these resources without the APFS ISO, which we will eject later. Now we need to edit the startup file to load these files during the boot sequence. We therefore type edit startup.nsh and press enter. We are taken to a text editor. Here we can enter commands which will not be executed until the whole file is run. Again, each of these commands can be copied from the written description. We enter an echo off command, followed by 3 commands loading each of the files copied from the APFS ISO. With the 4 lines entered, we press Ctrl Q. With the file modified, the editor requires us to confirm the save by pressing Y. We are returned to the shell prompt, where we type exit. Then we simply select the option to continue. We are returned to the shell prompt, where we type the map command map-r. The results of the map command show that where we previously had access to FS0 and FS1, we now have additional access to FS2, FS3 and FS4, and this is the impact of the addition of the APFS drivers. To fully appreciate where we're heading with this, we're going to jump ahead to the completed startup file. You'll recognise the first 4 commands as those we've already input and saved. The remaining 4 lines will therefore load the file boot.efi from within the directory System Library Coreservices, found at FS2, accessed following a drive remapping made possible by loading the APFS drivers. The issue that constantly troubles these projects is this number, which varies with each installation. The value is typically FS2, but it could also be FS3, FS4, and even FS0 or FS1 under certain circumstances. We provide this information by way of context because our next task is to find the correct value by searching for it. So we know that somewhere between FS0 and FS4, we're looking for a directory named System. We will therefore check each resource, starting by typing FS0: and pressing enter. With the focus changed to FS0, we type dir and press enter to reveal its content. We're looking for the system directory, and it isn't here, so we move on. We type FS1: and press enter. Then we type dir and press enter, and there's nothing there. So we move to FS2, where the dir command reveals the system directory. We've found our target, and it's located in FS2. We make a note of this. If this hadn't worked, we could check FS3 or FS4. The results for FS4 do present a problem for us, as there's a second system directory found here, which, should FS2 fail, we would immediately try. For now, to keep things simple, we'll consider that FS2 is the correct answer. Now we need to add extra detail to our startup file. We type FS0: and hit enter, before typing edit startup.nsh. We're back to the text editor with the startup file as we left it, and we add extra lines. We begin with the map command, and then we add the location which we have just discovered for the System Library Coreservices directory. In this example, it was located at FS2, so we enter FS2:. This can vary between installations, so what you type here will be determined by the results of your testing, but it will be between FS0 and FS4. Then we simply change focus to System Library Coreservices and launch the file boot.efi. With the extra lines added to our startup file, we press Ctrl Q to exit and press Y to save the changes. We return to the shell prompt and type exit, before simply selecting the option to continue at the next screen. Hopefully, you'll see a flurry of white text before the screen darkens. If you've made it this far through the tutorial, your reward is now by far the simplest part of the installation, performing a simple setup and personalisation of macOS. We select our country of residence, then click continue. Our region appropriate written and spoken languages are pre-selected, and we have the option to customise, or again click continue. We again click to continue at the data and privacy screen, and as we're purely experimenting, we have no information to transfer to this virtual Mac, so we click to continue again. As we're running macOS on non-Apple hardware, we'll retain our anonymity by not signing in with our Apple ID, so we click Setup Later, and are required to confirm our intention to skip at the drop-down. We click to agree to reading the terms and conditions, and one day we might, but not today. We'll also click the drop down to promise that we've read the agreement, but we might also have our fingers crossed behind our backs where Apple can't see. We advance to the account creation screen where we select our icon. As we were sporty in the last video, we'll show our musical side in this one. We enter our full name, which automatically populates the account name field. We now enter our password twice for confirmation. We're not keen on giving cryptic clues to help hackers, so we opt against a hint, then click continue. We've never trusted Express settings, so we turn over those particular rocks by clicking customize settings. As we're experimenting, we leave location services off, and we're again required to confirm this. As always, time zone can be entered by clicking the map, using the drop down, or typing directly, and we localize accordingly. At the analytics screen, we deselect the option to allow Apple to look at the telemetry of our decidedly non-standard Mac. If you've watched our videos before, you'll know that we view screen time restrictions as agents of purest evil, and we haven't evolved our technology to this stage only to then restrict its use. We're proudly addicted to our tech, and we select setup later, by which we mean when hell freezes over. As we're still definitely on the light side, we'll retain that option before clicking continue. There follows a brief moment of automated setup before we finally see our Catalina desktop. We need to clear the keyboard identification screen, so we click continue. To complete the identification, we simply press the key to the right of left shift. With that, we click done. Next, we can eject the APFS ISO as we've successfully copied its content. We simply right click it and select the option to eject. We now see our unobstructed desktop running under Windows. Now there are some known issues on which we'd love your thoughts. There's an absence of sound, and indeed devices don't appear to be recognised. No amount of experimentation with the virtual machine settings appear to rectify this, so if you have a solution, we'd very much welcome your suggestions in the comments. We're also aware that performance isn't exactly stellar, and the virtualised environment was never going to be any match for the genuine article. Again, we'd be delighted to hear any of your performance tweaks. We now return to keyboard and mouse support. To ensure that they function in a Mac guest, you will almost certainly need the VirtualBox extension pack, downloadable from the link shown on screen now and in the written description accompanying this video. Click the all supported platforms link to begin the download, which is quite small at just over 22 megabytes. Returning to the main VirtualBox interface, we click File, then Preferences, and at the Preferences screen, we navigate to Extensions, clicking on the plus icon in the upper right. At the Selection panel, we navigate to our downloaded extension pack and open it. We click Install to confirm our intention, then scroll through the license terms. Once fully scrolled, the option to agree is enabled, and clicking it installs the extension pack. With the pack installed, keyboard and mouse should be enabled in our virtual Mac. Finally, we're continuing to produce these tutorials and refine the method to improve it with each new release. If you'd like to be the first to see our latest content, we'd love you to subscribe. Thank you very much for watching this video. If you found it useful, please consider subscribing by clicking the logo on screen now. If you'd like to see more, there are 2 suggestions currently on screen. If you have a better, faster or more economical solution, let us know in the comments. We'd love to hear from you. You're also welcome to follow us on Twitter. Until your next tech fix, goodbye.